Hello, here we're talking about Laplace transformation, and we're going to start with the elementary ideas of Laplace transformation, and I'll give you some of the proofs here. Okay, first thing, what is Laplace transformation? Laplace is transforming a function of time to a function of frequency, or once we're talking about inverse of Laplace, that means we're transforming a function of frequency to a function of time. Now let's start with Laplace transformation. This is the formula. Laplace of f of s, which is function of s is standing here for frequency, equal integration from 0 to infinity function of time e to the power of minus st dt. S must be greater than 0 here. Okay, so here I'm going to give you some notes that would be helpful in solving the next examples or doing the proofs for the Laplace. So the first note is saying e to the power of infinity equal infinity. Second note, e to the power of minus infinity equal 0. Third one, e to the power of 0 equal 1. And also you might need to know this integration by part. You might need to integrate by part once you're doing the examples of Laplace. U times v equal integration of u dv plus integration of v du. And these are also another important rules that you must memorize that will help you in working on the Laplace transformations. I think you're already familiar with this type of rules. Okay, and these are the Laplace transformation table. There are lots of Laplace transformations here, and I will start with this one. I will prove the first proof that I want to make is that Laplace of 1 equal 1 over s. Okay, first thing, let me remind you with the formula. So this is the formula that we're going to use. Laplace of function of s equal integration from 0 to infinity f of t e to the power of minus st dt. So here our function of t is considered as this one. So I will plug, instead of this f of t, I'm going to plug in 1. From 0 to infinity, f of t, which is 1, times e to the power of minus st dt. So now here, once you multiply this one, you'll find the same idea, which is e to the power of minus st dt. Next, I want you to integrate this one. Once you integrate it, it will be e to the power of minus st divided by negative s. Negative s is the coefficient of this t is going to be divided. Anyway, it will be from 0 to infinity. So first thing, I will start with plugging the infinity instead of t. We can take 1 over negative s as a constant number. We can take it out because it doesn't do anything with the plug-in. So e to the power of negative s multiplied by infinity minus now the smaller number, which is e to the power of minus s times 0. Okay, if you remember the previous notes that I gave you, we already decided that e to the power of negative infinity, look, we said that s is positive, so negative times infinity will be negative infinity. This is going to give me 0. E to the power of negative infinity is 0. S times 0 will give you 0, so e to the power of 0 is going to be 1. So 1 over negative s will be multiplied by 0 minus 1, which is negative 1. So negative with negative will be cancelled to give you 1 over s as a positive. So Laplace of 1 equal 1 over s. Okay, good. This is the first proof that we made. Now let me give you another proof. Let's prove that Laplace of e to the power of at equal 1 over s minus a. Here s is supposed to be greater than a. Again, I'm going to go through the same steps. I will plug in this in the formula. Laplace of e to the power of at equal integration from 0 to infinity f of t. Now f of t is e to the power of at multiplied by e to the power of minus st dt. Now here you can see that you have the same base. So I can add the powers, the exponents, e to the power of at minus st dt. What I did here is adding the exponents. Now you have t and t. What if I take it out as a common factor? E to the power of t a minus s dt. So I took out t as a common factor here. Good. Now I can simply integrate. It will be e to the power of t a minus s over the coefficient of t is a minus s. Okay, this will be from 0 to infinity again. So now I can start to plug in the values here instead of t. This number can be considered as a constant. You can take it out as 1 over a minus s. Here it will be e to the power of t, which started with infinity, a minus s minus e to the power of 0 instead of t, a minus s. Okay, here I want you to know something. Here I gave you something that s is greater than a. So a small number, s is greater than a. Small number minus a big number will be negative here. So infinity times negative will be negative infinity. And if you remember, we agreed that e to the power of negative infinity will give you what? This is going to be 0. And anything times 0 will give you 0. So this will be e to the power of 0, which will be 1. So here you'll be left with 0 minus 1. So that means here you can multiply 1 over a minus s by negative 1. So it will be minus a plus s. I can rewrite it in the form of s minus a. So here I proved that Laplace of e to the power of at equal 1 over s minus a. Okay, let's go to our third proof. I want to prove that Laplace of cosh at, cosh means hyperbolic cosine at, equal s over s squared minus a squared. So here I'm going to use the hint that cosh at equal e to the power of at plus e to the power of minus at over 2. So I will use this hint to be able to find the Laplace of cosh at. So here instead of writing cosh at, I will write Laplace of e to the power of at plus e to the power of minus at over 2. Instead of using the long formula, it's simpler to make a shortcut here, which is I can take out the half because it's a constant number, so it will be half Laplace of e to the power of at plus e to the power of minus at. Now I can distribute this Laplace. It will be 1 over 2 Laplace of e to the power of at plus Laplace of e to the power of minus at. Good. Once you reach this step, if you remember the previous proof that I gave you, it says that Laplace of e to the power of at equal 1 over s minus a. So here Laplace of e to the power of at will equal to what? 1 over s minus a. plus, again I'm going to use the same thing, but here take care that a is negative, so a is negative here, so you'll have another negative here. Two negatives together will make it positive, so this will be 1 over s plus a. Okay, I hope here you understood what I did. Minus a, here the formula was saying it's a minus, but if you have a minus a here, minus with minus will give you positive a. Now I can make this one more simpler. It will be 1 over 2, and I'm going to make LCD here, which is the difference between two squares. It will be s squared minus a squared, here s plus a plus s minus a. Good. So I can make it more simpler here. You can cancel out the a with the minus a. 1 over 2, s plus s will give you 2s over s squared minus a squared. So now here I can simply cancel this 2 with the half, and I'll be left here with s over s squared minus a squared. So here we simply do our proof. Okay, let's do one more proof, which is Laplace of sinh at will be a over s squared minus a squared. Again, here I'm going to use a simple hint that sinh at equal e to the power of at minus e to the power of minus at over 2. So here this hint will make things very easy. Instead of using this sinh, I can plug in this value. Go for the same idea, take out the half, so you will be left with 1 over 2 Laplace of e to the power of at minus e to the power of minus at. Now I can distribute this Laplace for both. So once I distribute this one, again I'll remind you that Laplace of e to the power of at equal 1 over s minus a. So once you remember this, we can simply substitute this one by the answer, which is the Laplace of e to the power of at is 1 over s minus a minus, same thing here again. If you have a minus, here it will be minus a. Two minuses together will give you a plus, so here it will be s plus a. Again, make it simpler by finding the LCD. It will be difference between two squares, which is s squared minus a squared. Here you'll have s plus a minus s minus a. I will open the bracket. Minus a minus minus will give you plus a over s squared minus a squared. Here I think that we can simplify minus s with s, and we'll be left with 2a, so it will be 1 over 2 times 2a over s squared minus a squared. Again, here you can simplify the half with the 2, and the answer will be a over s squared minus a squared. So we proved that Laplace of sinh at equal a over s squared minus a squared. Okay, I'm going to continue in the next videos. This is enough for now.